Hello students. In CET and JEE mains, we will get many questions from the chapter Relations and Functions. So for this relations and function, set theory is basic here. So if you want to solve the questions from this relations and function, you must thorough with the set theory. That is the main concept sets here. There are many time saving results. If you know those results, we can easily solve the questions from the chapters relations and function. So in this video, we will discuss some of the important questions from this chapter here. The first question is, let R be a relation on N defined by R is equal to, within the flower bracket, order pair 1 plus x, 1 plus x square, such that x is less than or equal to 5 and x belongs to N. Which of the following is false? So there are some statements. We have to find which statement is false here. Let's see the statement here. The first statement is R has the elements. These are the elements of the relation R. Second one will be the domain of R is this one. Range of R is these numbers. And the fourth option is none of these. So for that, first we have to discuss what is the relation R here. So the relation R is defined as set of all order pair 1 plus x, 1 plus x square, such that this x belongs to set of all natural number and less than or equal to 5. That means x can take the value 1, 2, 3, 4, 5 here. So if we substitute the value of x in this order pair, we will get the elements here. So when x is equal to 1, so 1 plus 1, 2, and here 1 square, 1 plus 1, 2. So 2, 2. Yes, this is that. Then when x is equal to 2, 2 plus 1, 3, and here 4 plus 1, 5. So this is the second element. When x equal to 3, 3 plus 1 is 4, and 3 square, 9 plus 1 is 10. Yes, this is the third element. When x equal to 4, 4 plus 1 is 5, and here 4 square, 16 plus 1 is 17. When x equal to 5, 5 plus 1 is 6, and 5 square is 25. 25 plus 1 is 26. So here they are given 25. So this is not. Here should be 26. So clearly here itself we got that this will be the false statement. If you want, you can check with the remaining two here. Domain of R is 2, 3, 4, 5, 6. This is correct. And range of R is 2, 5, 10, 17, 26. So this is also correct. You know that in a order pair, first element always gives the domain of the relation and second element always gives the range of the relation here. Therefore, here the answer is option A. We'll move to the next problem, second problem. If A is equal to, this is a set has these three elements, B has three elements and C has three elements, then what is A minus B cross B intersection C? So cross is cross product of these two sets. We know that cross product of the two sets is collection of all order pairs such that first element always belongs to the first set and second element always belongs to the second set. So these are the options here. Let's check. So we have A minus B. So A minus B, set of all elements of A which are not in B. That is only the element A, because B and C belongs to the set B here. Therefore, this has the element only A here. Then B intersection C, the elements common to B and C here. So the elements common to B and C is C and D. Therefore, B intersection C is equal to C, D. Now we have to take the cross product of these two sets. Therefore, order pair A, C and order pair A, D. That is the element of this Cartesian product. Therefore, answer is option B. Next one will be, if F is a relation from R to R and G is a mapping, F is a mapping from R to R and G is a mapping from R to R, defined by f of x is equal to 2x plus 3 and g of x is equal to x square plus 7. Then the value of x such that g of f of x is equal to 8. So we have to find the values of x here. What are the values of x? So g of f of x. So this is the definition of the composite function. That is g composite f of x is nothing but g of f of x. So that is the value of that is equal to 8 here. So we have to check which option is correct here. So we apply the definition here. G of f of x is equal to 8. This is given. G of f of x is 2x plus 3. So g of 2x plus 3 is equal to 8. Now apply the function g here. So in place of x we have to write 2x plus 3 here, composite function. So 2x plus 3 whole square plus 7 equal to 8. After simplification you will get one quadratic equation. Square is there, so quadratic equation. You know that for any quadratic equation there should be a two solutions. So you will get the factors x plus 1 into x plus 2 equal to 0. So these two are the factors. A into B is equal to 0 implies either A is equal to 0 or B equal to 0. Using that concept, the values are x is equal to minus 1 or x is equal to minus 2. Therefore, option is C here. Next, we move to the fourth problem. The function f from x to y defined by f of x is equal to sin x is 1, 1 but not on 2. If x and y are respectively equal to, we have to find what is the domain and range of this function f. So f of x is equal to sin x is 1, 1 but not on 2. So the function sin x is 1, 1 but not on 2. So these are the four options here. We have to check which option is correct. So we know that sine function, actually the domain of the sine function is set of all real number and the range for the sine function is closed interval minus 1 comma plus 1 here. If I take entire real number as a domain, then sine function is not a 1, 1 function. So for that we have to restrict the domain of this sine function as 2 closed interval minus pi by 2 to plus pi by 2. So we have to restrict the domain to closed interval minus pi by 2 to plus pi by 2 or plus pi by 2 to 3 pi by 2, like that. So we have to restrict. We have to divide the entire real number system into these intervals here. Now, if I instead of real number, if I take this as the closed interval minus pi by 2 comma plus pi by 2 is a domain and this will be the range, then clearly sine function is both 1, 1 and on 2. So we know 1, 1 for every element of this set X have distinct images in Y. So every element of the set X has distinct images in Y. So that defines the 1, 1 here. And on to means for every element or for an element Y, for an element belongs to Y, there exists an element in X such that f of x is equal to Y. So that is the range of the function, or if the codomain set, entire codomain set is the equal to range set, then we say that the function is on to here. So this is not the case. First one is not the option here because closed interval 0 to pi and here 0 to 1. If I consider this one, this is not 1, 1. If I consider this interval 0 to pi, This is not 1, 1 because the range is 0 to 1 here. We cannot add all the values here itself. Therefore, this is not 1, 1. Therefore, this is not the option here. Next, we move to the second option. Minus pi by 2 to plus pi by 2, and the value of y is, set y is closed interval minus 1 comma 1. Just now we explained here that this is both 1, 1 and onto. We have to find x and y such that function, sine function is 1, 1 but not onto. So this is not the answer. Next, I'll move to the option D here. Here the range is, or set x is set of all real number and set y is set of all real number. This is also not possible because we know that if the codomain, which is not onto, clearly the fourth one is not onto because codomain set is not equal to range set. Range set is closed interval minus 1 comma plus 1, but codomain set is R. But if I consider this R domain as a set of all real number, that is not a 1, 1. That indicates that function f of x equal to sin x is not a 1, 1 function. Therefore, the only option is option C. Clearly, if I take domain as closed interval 0 comma pi by 2 and range as closed interval minus 1 comma plus 1, the function is 1, 1 but not onto. So there exists some elements of this set, range set, such that there is no pre-image here, but that is 1, 1. So the option is option C. The next question is, if a relation R on a set A having the elements 1, 2, 3 be defined by R is equal to the order pair 1, 2, then R is, we have to check whether R is reflexive, symmetric, transitive or is an equivalence relation. So we check with all the options here. R has the elements order pair 1, 2. So we know that for reflexive, for every element of the set A in which order pair 1, 1, 2, 2, 3, 3 should belongs to R. So clearly this is not a reflexive relation. When comes to the option C here, symmetric, there is an order pair 1, 2 belongs to the relation R. If order pair 2, 1 belongs to the relation R, then we say that this is symmetric. But there is no order pair 2, 1 here. Therefore, clearly this is not a symmetric. Hence, option D will not be the option because equivalence relation is nothing but if the relation is reflexive, symmetric and transitive, then only we say that that relation is an equivalence relation. So the option is of D here, that is transitive. So we'll check here. We know that for A, B, C belongs to A, the given set A, transitive means whenever A, B belongs to R and B, C belongs to R, then A, C belongs to R. That defines the transitive relation. But there is only one order pair 1, 2. To compare, there is no other order pair here. If we compare, for comparing, if there is one more order pair such that this condition holds, so after that this order pair A, C does not belongs to R, then we say that there is no transitivity here. So the relation is not a transitive. But in this case, there is only one order pair 1, 2. To compare, there is no other order pair. So we conclude that this relation R is a transitive relation. So any relation having only one element, that relation is known as a transitive relation here. Therefore, option. We move to the next one. Let F is a mapping from R to R defined by f of x is equal to square root of x square minus 3x plus 2. Then domain of this function f is. We have to check the domain of the given function. So we know that for the square root function, square root of negative is not defined. That is not a real number. That is, we know that that's a complex number, some other set here. So square root of negative is not defined. So maybe 0 here. Therefore, x square minus 3x. This f of x is defined only when x square minus 3x plus 2 is greater than or equal to 0. So that is this one, greater than or equal to 0. So if I factorize this one, this is a quadratic equation. If I factorize this, you will get x minus 2 into x minus 1, which is greater than or equal to 0 here. This is possible. X minus 2 into x minus 1 is greater than or equal to 0 is possible only when x is greater than or equal to 2 or x is less than or equal to 1. Because when I take x is greater than or equal to 2, if I take x equal to 2, 2 minus 2, 0, so this will be equal to 0, and greater than 2, this term 3 minus 2 plus 1, here 3 minus 1 plus 2, both the factors positive. So this is greater than 0. Or if I take x equal to, that's the value of x as less than 1, in that case both the factors negative. So product of these two is greater than 0 only when both are positive or both are negative. So this is possible only when x is greater than or equal to 2 or when x is less than or equal to 1 here. Therefore, x greater than or equal to 2 means 2 to up to infinity, and x less than or equal to 1 means 1 to this minus infinity to 1, including 1 and 2. Therefore, answer for this is option. The seventh problem will be, which of the following function is 1, 1? So there are some functions, we have to check which function is 1, 1 here. The first option is f is a mapping from R to R defined by f of x is equal to cos x. Let's check this one. So we have one property in a trigonometric relation, that is cos x equal to cos y only when x is equal to 2n pi plus or minus y here. That means f of x1 or f of x is equal to f of y, which implies x equal to y, then only we say that function is 1, 1, isn't it? But here x can take many values as n varies here. Therefore, x cannot be equal to 1. Therefore, option A will not be a option. That is, the function is not a 1, 1 function. We'll move to the next one here. H is a mapping from R to R defined by h of x is equal to 2x square plus 1. If you take any negative values here, that will become positive, plus 1 here. Set of all real number to set of all real number. But that is not a 1, 1 here. Because for example, if I take the value 5, if I take f of or h of minus 1, h of minus 1 is equal to h of 1. For example, h of minus 1 is equal to h of 1. What is h of minus 1? H of minus 1 is minus 1 whole square into 2. 2 plus 1 is 3 and h of plus 1 is also 3. Images are same but elements are not same. Minus 1 is not equal to plus 1. Therefore, this is also not a 1, 1 function. Next we move to the option B here. G is a mapping from natural number to integer defined by g of x is equal to x square. Clearly I can say that this is 1 1 here, because if I take the function g of x1 square equal to g of x2 square, g of x1 square is equal to g of x2 square, x1 is equal to x2. This is the only possibility. There is no other option, because both x1 and x2 are belongs to set of natural number. In a set of natural number, there is no negative number here. So this is possible only when domain is set of all natural number. Therefore, clearly B is a 1 1 function here. And if you try to find the values here, option D, j of x is equal to tan x to the power 3. Here also this is an odd function. Tan function is an odd function. So minus 1 to the power 3 is equal to minus here. You will get the negative value itself. Therefore, option D is clearly, this is not a 1 1. Therefore, the answer is option B. The eighth one will be, define a relation R on the set A having the elements 1, 2, 3, 4 as x related to y. If x divides y, then R is, this is the relation, x divides y. So R will be reflexive and transitive, reflexive and symmetric, symmetric and transitive, and none of these here. So for that, first we have to write what is the relation here. Relation is defined as x divides y. X divides y. Y is divided by x, the first element. Second element is divided by the first element. So the elements are 1, 1, 1, 2, 1, 3, 1, 4. Then if I start with 2, only the option is 2, 4. Then the last option is 4, 4. So these are the elements of the relation R. So clearly R is not reflexive, because 1, 1, 2, 2, 3, 3 and 4, 4. If all these 4 order pair present in the relation R, then we say that that is a reflexive. But there is no order pair 2, 2 and 3, 3. Clearly R is not a reflexive. Therefore, clearly we can delete the option A and option B, because in option A and option B they mention that the relation R is reflexive. So A and B will not be the answer here. Let's check with the remaining. Let's check the symmetric. Order pair 1, 2 is there, but order pair 2, 1 does not belongs to the relation R. Therefore, clearly R is not a symmetric. Therefore, option C is not the answer here. So, option D, none of these. The next question will be, the number of functions that can be formed from the set A, B, C, D into the set B 1, 2, 3 is equal to. So we have to find the number of functions, distinct function from the set A to set B. There is one concept here. If the set A has m elements and set B has n elements, then the number of functions from set A to set B is number of elements of B to the power number of elements of A, that is n to the power m here. So using that concept, so we know that number of functions from set A to set B having m and n elements respectively is n to the power m. Here n is equal to 3 and m is equal to 4, therefore 3 to the power 4 here. So 3 to the power 4 will be the option Here 81. Therefore, answer will be option D. 10th question will be, let f is a mapping from R to R defined by f of x is equal to 1 by x. For all x belongs to R, then f is. So these are the options here. F is maybe a bijective onto function, or f is not defined, and 1 function. So f of x is equal to 1 by x for all x belongs to R. But we know that when x equal to 0, the function is not defined. They didn't given the condition that x is not equal to 0. Here given that for all x belongs to R, f of x is defined as 1 by x. So this is a simple question. First, we have to think whether function is defined or not. So here the function is not defined at x equal to 0. Therefore, answer will be option C. The next question is, the relation R having these elements on a set A had the elements 1, 2, 3. We have to check one of these options here. Which one is correct? So here the relation R having the elements here. To say that this is a reflexive, order pair 1, 1, 2, 2, 3, 3 should belong to the relation S, having all the 3 elements. Therefore, this is clearly reflexive. So here also reflexive is there. In the option B also reflexive is there. And we have to check whether these two are, one of these two are the answers or some other answers. Next, we check with the symmetric. Order pair 1, 2 is there, but the order pair 2, 1 does not belong to this relation R. Therefore, this is clearly not a symmetric. Therefore, we can clearly say that option A is the answer here. If you want, you can check the transitivity. 1, 2 is there, 2, 3. So, 1, 3 that is belongs here. Therefore, clearly this is transitive. There is no other choice here. 2, 3. If I take 2, 3 and 3, 3 again 2, 3 belongs. Clearly the relation R is transitive. Therefore, this will not be the answer. Clearly C is also not a answer because this is not a symmetric. And fourth one is also not a answer here because the given relation R is transitive but not a symmetric. But here given that neither symmetric nor transitive. Therefore, the correct answer will be reflexive but not symmetric. Therefore, answer is option. The 12th question is, let L denote the set of all straight lines in a plane. Let a relation R be defined by x is related to y if and only if x is perpendicular to y. So x, y belongs to L. Then R is x is perpendicular to y. Then only we say that x is related to y here. So we know that. So these are the options here, either reflexive, symmetric only, transitive only, or none of these here. We'll check that one. So I'll take two lines. One line is x and another line is y such that the line x is perpendicular to line y. So this is the line x and this is the line y here. For to say that symmetric, order pair x, x belongs to the relation R. So we know that a line cannot be perpendicular to the same line or cannot be perpendicular to itself. Therefore, this is not a symmetric. First one is not an option. Next one. A line may perpendicular to any other line. X is perpendicular to y and clearly I can say that y is perpendicular to x. So this is symmetric. Now we have to check whether this is symmetric only or this also satisfies the transitivity. So x is perpendicular to y and y is perpendicular to some other line. I'll take z. X is perpendicular to y, y is perpendicular to z. To say that R is a relation, transitive relation, if x is perpendicular to z. If I move the line x and this is the line z. So x cannot be perpendicular to z. X and z are parallel to each other. Therefore, the given relation is not a transitive. So, this is the option. The given relation is symmetric only. The next one, total number of equivalence relation defined in the set S having the elements A, B, C, that is having 3 elements. So these are the options here. We can remember by this one by time saving results. I'll give the explanation of this. The smallest equivalence relation is the identity relation. So we have to collect how many equivalence relations are there for the set S here. The smallest one will be this one. Order pair A, B, B, C, C. So this is reflexive, symmetric and transitive. So R1 is an equivalence relation. Next we move to one bigger set, that is by considering two order pairs of two distinct elements, here having same elements. So order pairs of two distinct elements such that R2 is defined as A, B, B, A. So if I add the order pairs of two distinct elements like this, this is also a equivalence relation. This is symmetric as well as transitive. A, B, B, A. So A, A present here. A, B, B, B. So A, B present here. Therefore, R2 is a equivalence. Similarly, R3 and R4. R3 is nothing but by considering all these three, instead of taking order pair B, A, B, I'll take A, C and here C, A. I'll consider that as the R3. And R4 is these three elements along with B, C and C, A. So these are the three relations. This shows that equivalence relation. And is the one more relation, the largest equivalence relation will be containing all this union of R2, R3 and R4. So A, B, B, A, C, C, A, B, C and C, B here. Therefore, total 1, 2, 3, 4, 5. So the total number of equivalence relation defined in a set having 3 elements is equal to 5. This is always true. If you take instead of ABC 1, 2, 3, any set having 3 elements has the number of equivalence relations is 5 here. Therefore, answer is option. 14th will be the relation S defined on the set of real numbers by the rule A is related to B. A, S, B. That is related. S is defined. Relation here. If and only if A is greater than equal to B is an. We have to check whether this is reflexive or first option, second, third, or this is an equivalence relation set. That is reflexive, symmetric and transitive. We'll check here. To check this one, we'll take element here. So A is equal to, if I take one element A belongs to the set S, A is equal to S. Yes, order pair A, A belongs to set S here. Yes, that is a reflexive. Next one. To check the symmetric, I'll take one order pair A, B. So if I take the order pair A, B, that belongs to the relation S, then order pair B, A also should belongs to the relation S here. If order pair A, B belongs to S means A is greater than or equal to B. If order pair then order pair B, A should belongs to S implies B is greater than or equal to A. So this is not possible always. So 1 is or 2 is greater than 1, but 1 is less than 2. That is not greater than 2 here. Therefore, symmetric is not possible. If you check with the transitive, maybe transitive. A comma B belongs to the relation S and B comma C belongs to the relation S. Then A comma C belongs to the relation S here. Therefore, clearly this is reflexive and transitive but not symmetric. So, A will be the answer here. If you want, you can check. So, option B having symmetric transitive. Clearly, this is not a symmetric. Therefore, this is not a option. In option C also, neither transitive nor reflexive but symmetric. Yes, clearly this is not a symmetric. Therefore, this is not the option. Equivalence relation. Clearly, this is not a symmetric. This is not the option. This will not be the option. For all the three, this is not a symmetric. That will be the reason. Option here. 15th one. If A is a function mapping from n to z defined by n is a set of all natural number and z will be the set of all integers, defined by f of n is equal to n minus 1 by 2 when n is odd and minus n by 2 when n is even. We have to check whether the given function is 1 1 but not on 2 but not 1 1, 1 1 and on 2. That is a bijective function, neither 1 1 nor on 2. Let's check one by one. If x and y both belongs to the set of natural numbers and both are even, then clearly the given function is 1 1. Because if both are even, when n is even, f of n gets the value minus n by 2. In both the case, you will get this one. Therefore, in that case, this is 1 1. Clearly, when both are odd, then also the function is 1 1. We won't consider the case when one is 1 even and one is odd here. That is the exceptional case. So, we consider only these two cases. In all these two cases, both the case, function is 1 1. The next one is onto. We know that the definition of onto. For every element of this set or for an element of this set Z having at least one pre-image in the domain. For any or for every element of this set Z have at least one element or one pre-image in N. So that defines the onto, or in general codomain set is the range set, then we say that the given function is onto. Since each negative integer is an image of even number, for every even number, negative integer is an image, and also for each positive integer is an image of odd number. So, each positive integer is an image of odd number. That means, for every positive integer there is a pre-image, that is an odd number, and for every negative integer there is a pre-image, that is an even number. So, entire Z is the range set. Therefore, the function is both 1 1 and onto. Answer is option. The next one is, let A is the set of all real number other than 3, B set of all real number other than 1, and F is a mapping from A to B defined by f of x is equal to x minus 2 by x minus 3. We have to check whether f is bijective, that is 1 1 and onto. F is 1 1 but not on 2 but not 1 1, or none of these. So for that we take the elements x comma y belongs to A. Then f of x equal to f of y implies x equal to y. So if we simplify this, x minus 2 by x minus 3 equal to y minus 2 by y minus 3. So you'll get all the term get cancelled, then you'll get x equal to y. Therefore clearly this is 1 1 function. Now we have to check. So C is not the answer here. So on 2 but not 1 1. So this is not the answer. We have to check whether A or B. Clearly D is also not the option here. Maybe A or B will be the answer. We check that one. So for an element y in a set B is an arbitrary element such that f of x equal to y here. So f of x is equal to y, or x is equal to this one. B is a set having the element set of all real number other than 1. So here we cannot put y is equal to 1 because that is not an element of B. Therefore clearly this is the element here. So x is equal to this one is a element. Hence for all y belongs to B, there exists one x in A such that f of x is equal to y here. So this clearly belongs to this A here. So x is equal to this one clearly belongs to A because we cannot put y is equal to 1. Hence the given function is onto. F is both 1 1 and onto implies f is bijective. Therefore answer is. The next one will be set A has 3 elements and set B has 4 elements. The number of injection or injective mapping or 1-1 mapping that can be defined from A to B is. So we know that if the set A has m elements and set B has n elements such that m is less than n, this is also a time saving results, then the number of 1-1 functions from A to B is NPM permutation here. So here since 3 is less than 4, injective mapping from A to B is 4P3. So 4P3 is nothing but 4 factorial by 4 minus 3 factorial. The value of this is 4 factorial. So 4 factorial value is 24. Therefore answer is option C. The next one is the number of bijective functions from set A to itself when A contains 106 elements. These are the options. We have to check which one will be the number of bijective functions. So we know that the total number of bijective functions or bijections from a set containing n elements to itself is n factorial. So the given set has 106 elements. Therefore, the number of bijective functions is 106 factorial. So one more time saving results. If you know this one, you can write the answer for this question. So answer will be option. The 19th one, again is a composite function here. F of x is equal to x minus 1 by x plus 1. Then f of x is. These are the options. We'll check here. F of x is f of x is again this one. If I substitute the values after simplification, you will get minus 1 divided by x here. So option B. The last question of this session will be the binary operation star defined on n by a star b is equal to a plus b plus ab for all a comma b belongs to n. So we have to check whether this star is commutative only. associative only. Commutative and associative or none of these. So we know that commutative means A star B is equal to B star A. So clearly here A plus B plus AB is equal to B plus A plus BA. If you interchange A and B, you will get B star A. Therefore, this is commutative. Now check with the associativity. So A star B star C. So A star B star C is A plus B plus AB star, compare with this one C here. So star C, binary operation C. So this is nothing but whenever A is there, you have to write entire term. Wherever B is there, you have to write C. So A plus B plus AB, this is the term A. Then plus B, that is nothing but C, plus A times or A plus B plus AB times C. So this will be equal to total, finally you will get A plus B plus C and the two letter terms AB plus BC plus AC and the last term will be ABC. This is the simplification of the left hand side. Similarly, if you simplify the right hand side, you will get the same answer. Therefore, this is associative. Hence, the given binary operation star is both commutative and associative. Answer will be option C. Thank you.